Topic 1, Form 5, Wave. Dear student, under this topic, we'll be learning about water wave, light wave, sound wave, and electromagnetic wave. Our first lesson will be about the motion of waves. An oscillating or vibrating system along a line about a fixed central point produces a wave. Example of waves: water wave, light wave, and sound wave. A wavefront is a line which joins all the phase points. There are two types of the wave: transverse wave and longitudinal wave. And a transverse wave is a wave which the vibration of the particles is perpendicular to the direction of the propagation of the wave. Example of a transverse wave: water wave, light wave, and electromagnetic wave. While a longitudinal wave is a wave which the vibration of the particle is parallel to the direction of the propagation of the wave. Example of a longitudinal wave is sound wave. Dear student, the next concept will be amplitude, period, and frequency of the wave. Amplitude of a vibrating system is the maximum displacement from its equilibrium position, while period of a vibrating system is the time taken to complete an oscillation. Frequency is the number of a complete oscillation made in 1 second. Dear student, the next concept will be the relationship between the speed, wavelength, and the frequency. The relationship between the speed, wavelength, and the frequency can be stated by the formula of V equals to F lambda. SI unit for the speed will be meter per second, wavelength meter, and frequency will be hertz or per second. Dear student, the next lesson will be the damping and resonance. To understand the concept of a damping, let's look at the diagram shown in the slide. The amplitude of the oscillation of the simple pendulum will gradually decrease and become zero when the oscillation stops. The decrease in the amplitude of the oscillating system is one called damping. An oscillating system experiences damping when its energy is drained out as a heat energy. Two factors which contribute to the damping will be the internal damping and external damping. Internal damping of the system is the energy loss due to the extension and compression of the molecules in the system, while external damping is the loss of energy to overcome the frictional force. Dear student, the both graph in a slide shows how amplitude and the displacement decreases against the time. Damping in oscillating system causes decreases in amplitude and energy, but the frequency does not change. Resonance occurs when the system is made to oscillate at the frequency equivalent to its natural frequency by an external force. Dear student, the first phenomenon of the wave will be the reflection of the wave. Reflection of the wave occurs when a wave strikes an obstacle. The waves undergo a change in the direction of propagation when it is reflected. When reflection occurs, speed, wavelength, and frequency does not change. Direction of the reflected wave will change and amplitude of the reflected wave decreases. Second phenomenon, refraction of the wave. Water wave undergo refraction when there is a change in the speed of the wave. As what you can see on the slide, water wave undergo change in the velocity and the wavelength when passing through from the deep water to the shallow water. When a water wave transmitted from a deep water into the shallow water, the wave is refracted towards the normal, and the wave are refracted away from the normal when the water wave transmitted from the shallow water into the deep water. Third phenomenon of the wave, diffraction. Diffraction of the wave is a phenomenon in which wave spread out as it passes through any gap or obstacle. Effect of the diffraction is obvious only if the size of the gap or obstacle are small enough and the wavelength is large enough. Dear student, the characteristic of the diffracted wave: frequency, wavelength, and the speed does not change, while the amplitude or the energy decreases. The last phenomenon of the wave, interference. Interference is the superposition of the two waves originating from the two coherent sources. Sources which are coherent produce a wave of the same frequency. Constructive interference occurs when the crest or the thrust of the both waves overlap to produce a wave with the crest and the thrust of the maximum amplitude. Destructive interference occurs when the crest of the one of the wave overlap with the thrust of the other wave, with the result that the resultant amplitude is zero. Diagram shows the interference of the wave where the constructive interference and the destructive interference occur.